David asked if I could put together a couple of slides on projects that I've been involved in that focus on health. Now, my background as an architect is predominantly working on projects that have had a focus on health. So this isn't just a couple of slides about different projects with a healthy housing specification. It gives a bit of context, because when we say healthy housing, the natural conclusion is that most housing then is unhealthy, which is quite true, actually. I'll just skip through that. But we build our homes predominantly from, toxic and inappropriate materials, stuff that is really bad for our health, that cause allergies, that, Georgina, you might have come across in being a virologist, I don't know. But it's not just the ill health to us as occupants. What we build from and the stuff that we throw away and the emissions from our homes cause pollution to the air, to the water, and to the ground. And they generate waste, which has all sorts of implications, which ultimately are bad for our health. We have all seen this in our homes, mold. We probably here are all aware of the impact that moisture has. But maybe not. This is a wonderful graph by somebody called Arundel and Sterling quite a few years ago now. But when it comes to moisture, when it comes to the amount of humidity in your homes, there's an optimum zone of 40 to 60% relative humidity. But it doesn't get rid of everything. But if the air is too dry, it's bad for you. It can dry out your mucous membranes. And if the air is too damp, then you can get mold and you can get dust mites and viruses occurring when your relative humidity is quite high. So there isn't an optimum zone. So moisture is a pollutant. And then some of the big pollutants that we deal with are VOCs, volatile organic compounds, and SVOCs. And these come from a spectacularly wide range of sources, and they all affect our health in different ways. And the reason that that's important is that as a species, we've been around Homo sapiens have been around for about 200,000 years, I think. And before that, it took about 1.8 million years for us to get to Homo sapiens. In that period, that 1.8 million year period, our physiologies have developed to deal with the things that are going to affect it in nature. So pollens, for example, temperatures, relative humidities, noises, stresses. Our bodies are used to that because over 1.5 million years, we've become used to these things and we know how to deal with them. But in the last 150, 200 years, the chemical industry has come into being, particularly so in the last 60 years since the end of the Second World War. And all of a sudden, in the last 60 to 100 years, our bodies have to now cope with a massive variety of things that it just has no experience of. So it's natural to worry, and it's right for us to have some concern about what impact modern synthetic building materials and the chemical components that go into them have on our bodies. Now, these are particularly relevant to two age spectrums, or two ages at the end of the spectrum, I suppose. And that's very young people, because when we're born and when we're very young, our physiological systems are developing. So they're incredibly susceptible to the impact of pollutants. Then when we get to old age, our bodies have gone through 50, 60, 70 years of life, and they have picked up susceptibilities, sensitivities to certain things, certain pollutants. So when we're very old, our nervous systems, our respiratory systems may have been weakened through lifestyle choices, through pollutants we've been exposed to through our lives, but we're incredibly susceptible when we're old to those pollutants. So being young and being old are the points of our lives where we're really open to be affected by what we're exposed to in terms of pollutants and chemicals. And we can see this. There's plenty of statistics to back this up, like the number of people who are being treated for asthma, the proportion of which are children. the extent to which multiple chemical sensitivity is being found across the world, but now in Scotland. And part of that comes from our exposure to an increased number of chemicals. And that increased number of chemicals has, as I mentioned earlier, it's come from development of the chemical industry, particularly after the Second World War. But there are two aspects to us being affected by chemicals in buildings and this wish to create healthiness in buildings. One is that we are exposed to a lot of chemicals. So as a principle, the first thing that we want to do is we want to reduce our exposure to chemicals in the first place. And that comes through where we build and what we build our buildings from. So that's the prevention bit. Then we've got the cure bit, and the cure for making our not very nice, our highly chemical buildings okay to live in is to implement mitigation measures. So that's things like ventilating our buildings. But over the last 10, 20, 30, maybe even 40 years, as we've started to seal up our buildings and we've stopped ventilating them as effectively as we did, we are reducing the air exchange, the amount of fresh air that comes into our buildings. And that is having a direct impact on our health. So yeah, as it says at the bottom, it's fair to presume that buildings have a direct impact on the health of occupants. There are plenty of academic studies that back that up. So this is just a list of chemicals that a lot of our synthetic building materials are made from. If you want to, go and Google one or all of these. And then, so for phthalates, for example, put phthalates health effects into Google's or isocyanates health effects into Google and prepare to be horrified. And they are frightening what these things do to us. And of course, they're impossible to see, they're impossible to smell, they're impossible to taste, and they're impossible to touch. So we don't know how much of these things we're surrounded by. You can measure them. I'm not going to go into this, but yeah, the health effects of these chemicals are quite frightening. And we as a construction industry, or we as a chemical industry rather, have measured the individual impacts of these chemicals on our bodies. So we know, for example, formaldehyde is a carcinogen. We know benzene is a carcinogen. We know that some flame retardants have a particular effect, but when we build our houses, we build them out of, well, as architects, Tom and I have 100,000 plus different materials and components that we can choose to put into the building we design for use. Now, each of those building components, it's not just going to have one chemical or two, it's going to have half a dozen or more. But then the chemicals in the carpet mix with the chemicals in the paints, which are different to the chemicals coming out of your lovely new kitchen. And scientists, they know what individual chemicals might do to us, but they have no idea what happens when chemicals mix, when chemicals interact. And that's called the cocktail effect. Nobody in the entire world has started looking at that because it's too complicated. And it's too complicated because there are over 500,000 chemicals in existence. And trying to work out how they all react with one another is an almost impossible task. So that was depressing, wasn't it? Let's have a quick think about what it is that makes housing healthy. And the first thing is choosing where we build them. So if we build our new homes beside the motorways, which we do, depressingly enough, on a regular basis, we are building our homes right beside a major source of pollution. So don't build your homes beside sources of pollution like power stations, like roads. And don't build them in areas where they're going to be flooded, because flooding has a much greater impact than just making things wet. If the ground is wet on a regular basis, then it encourages insects to come along and those insects may have, in the future, not here, not now in the UK, but in the future they may have carry disease like malaria. The other thing that makes housing healthy in terms of where we locate them is building them among other homes and close to amenities so that we have that social benefit, because health is a function of a variety of factors, one of the greatest being the social impact of housing. How we build and look after our houses is incredibly important. And building our homes so that they can be maintained is a really important thing, because if we can stop a small problem getting bigger, then we stop that tiny little gutter leak from creating a damp patch, which creates mold, which creates asthma. And what we build them from naturally has a big impact. So choosing non-toxic construction materials and energy efficient heating and lighting systems makes sense. But those first three things, they're all about what Tom and I might do as the architects. These are all decisions we make before you, as the person buying the house or having the house built for you, even come into it. The last one is equally as important as those first three, because we can design you a wonderful, clean, healthy house. If you, the occupant, then go in and use lots of chemical cleaning agents, you don't open the windows to ventilate it, you keep your kitchen sink full of water and mucky dishes, then clearly all of those things, the occupant factors, the behaviour, has a huge impact on how healthy a house can be. So it's those two sides that make houses healthy. Policy is looking at this. This isn't all just about enlightened architects and clients wanting to build nice homes doing stuff. There's an all-party parliamentary group in the House of Commons, which has been set up for healthy homes and buildings, and you can have a look at the papers they've put together, and they're pushing to make sure that healthy homes is looked at, or the health of homes is looked at an equal level to energy efficiency, because we're all talking about energy efficiency and carbon, but very few people are talking about health. Yeah, can buildings improve our health? Well, yes, in a word. The wee picture at the top right is a form of construction called massive timber, which is essentially lots of softwood planks all doweled together, and you can use those to make wall and floor and roof panels, like you can see in the picture below. Now, if you build from untreated timber and you use it to create homes, or I think this is a hotel that a company called Toma made quite a few years ago, it has a direct impact on your health. And the reason we know that is people who came to stay in this hotel, some of them were asked if they would be part of a scientific experiment, a health experiment. And the people who took part in this experiment had their heart rates measured for the week or so that they were staying. And the people doing the test found that the average number of heartbeats of the people staying in this hotel was reduced by 3,500 beats per night. And this was all attributed to the fact that this was a natural timber building built out of completely untreated softwood. So if you choose the right kind of building materials, it can lower your heart rate, which is fantastic. And there are other natural building materials that you may have heard of too, such as straw bale. And the two wee pictures in the top right, the one on the left is a panel from a company called Mod Cell, and the right is a company called Eco Cocon. And the project down below is Lilac, which some of you might be familiar with, is a mutual home ownership cooperative in Leeds, built with prefabricated straw bale panels. And they've measured the indoor air quality of these, and the homes have a very good indoor air quality. Straw, as it grows as well, it absorbs carbon dioxide. It doesn't use pesticides when you grow it. So this is a really good green building material that is good for the occupants living in. Now, another couple of projects that I've peripherally been involved in. The first one is one called Whole House Gardens, which is in Perth. And this was done by Gaia Architects practice that doesn't exist any longer, but I used to work with a long time ago. And this was a project to develop 14 1- and 2-bedroom houses in a very deprived estate in Perth. And this deprived estate in Perth had a number of residents with chronic health complaints like respiratory problems, vascular dementia, what else do they have? Some mobility problems. The occupants who were moving into these 14 homes were selected before they moved in. And the architects and the client worked with the occupants, the selected group of future tenants, and they calculated how many times they went to the doctor and what their prescription costs were. And after they moved in, about 2 years after they moved in, I think, the same occupants were asked about the number of doctor's visits and the amount of money that was being spent on prescriptions. And they found, as it says there, that there was a 75% reduction in visits to the doctor after moving in. And I think the reduction in cost, there was about a 30% reduction in costs of the medication that they were using. And the architects had a feeling that this would happen. So when they measured this and they got these statistics, they found out that, yeah, this is great. This is what's happening. And so they wondered why it was, and they attributed it to 2 things. The first was specification of building materials, and especially the internal finishes. So that's the flooring, the wall finishes, the kitchen units, paints. The specification of those things so that they didn't off-gas chemicals, or they off-gas the smallest level of chemicals into the indoor environment. And the second thing that they did was, as well as reducing the impact of chemicals in the building, they also developed a ventilation strategy that helped to push out at a very low rate any chemicals that did come into the building. And I'll not bore you with it, but if you are interested, the type of ventilation system they used is called dynamic insulation. And it effectively involves blowing air through the ceiling at a very low rate. So that warm air coming through the ceiling pushes everything out of your trickle vents in your windows. And it worked really effectively. The second project that I'm just going to mention is one I did in my own practice a few years ago. And this was in the village of Arisig, which is where I'm from, as it happens. And this was 10 affordable houses for rent. And in the village I'm from, we have 2 kinds of people, I suppose. There are people who are generally well, and there are people who are generally unwell. And Arisig Community Trust knows this. So they wanted to develop housing that had a good low allergy specification so that those moving in, whether they were well or whether they were unwell, they would have healthy housing to live in. And so the 2 different types of construction that we looked at for this were that massive timber, that lovely exposed timber building that you saw earlier. Just building the house out of those. And the other construction system we looked at was one of the prefabricated straw bale systems. For various reasons, the client decided not to go ahead with this, and they've just gone for a bog standard specification on the project, which, am I bitter about it? Yeah, a little bit, but it's incredible how cost has a huge impact on these things. The client didn't have enough confidence to push through with the low allergy specification. And the third project I'm just going to mention is one up in Braemar. And a couple of years ago, I started working with Rural Housing Scotland, which is an organisation that works with rural and island communities around Scotland to help them identify housing need and then help them to deliver the homes that they need to meet demand. So the project in Braemar is for 15 affordable homes for rent, kind of similar to the one in Arisig. It's all being built to passive house, and it's going to have low embodied carbon, which is really important. But one of the great things about changing from being an architect to going to work with Rural Housing Scotland was all of a sudden I got the opportunity to work with the client to say, energy efficiency is super important, particularly in Braemar, which is the third coldest place to live in the UK. But there's no point having super energy efficient housing if we build them out of petrochemical, highly toxic building materials that are going to impact the occupant's health. So this was a great opportunity to put together a brief for the project in Braemar that set out in detail the low allergy specification. And the two things really that underpinned that low allergy specification were a red list of building materials and chemicals. So there's, if you go and Google red list and sin list, there is a list of building materials and chemicals that you should try and avoid in buildings. And we use that as the backbone for this brief. And John Gilbert Architects, who are designing this for the community, they've taken that and developed a low allergy specification for the homes. So these will be lovely, warm, non-toxic homes. And an important part of that is making sure that the surroundings of these homes isn't going to pollute the houses too. So the landscape architects have developed a really carefully considered landscape specification around the homes too. So that was an awfully quick run through, wasn't it? We talk a lot about energy efficiency and carbon dioxide, but as I just said, there's no point in us building super energy efficient homes if they're built from materials that are terrible for our health and create a huge amount of pollution. So yeah, healthy housing is essential. But one of the options is, when you choose these building materials and these techniques and these components, they are generally better quality than the stuff that bog standard housing is built with. But the upshot of that is that they cost slightly more. They tend to last longer too. But through, how long have I been an architect? 15, 16, 17 years of being an architect. And Tom will attest to this as well. It's amazing how many people say something is healthy when it's actually not. So it needs quite a lot of work and time put in to make sure that whatever you're building from actually is healthy. And there are ways that you can check that. There's something called material safety data sheets, for example, that every component, every material is meant to come with, and you can check that to see whether it includes something toxic. If you've been through that process and you end up building a healthy home, you're not just building it for your health now, you're building it for your children, your grandchildren, future occupants' health and their benefit. But ultimately, this is a social investment that we're creating by creating healthy homes, because at the moment, our failing health as a nation is causing the NHS to come apart at the seams. Part of that is because of privatisation and Tory policies, which I'm not, this isn't the place for that. But the more we can do to improve our own health through the type of homes we build, the less pressure we end up putting on the NHS. But ultimately, creating those healthy homes is just about, it's about how the occupants use them as well as how we design and build them in the first place. Right, that was a whistle-stop tour. And David, I don't know if that met your brief or not, but I hope it was useful and vaguely interesting.